right, we're going to go over the first few problems on your test review on data and statistics. Let's take a peek at question number 1. Alan recorded his golf score the last 15 times he played. The golf scores are listed below. And we've got all of his golf scores. Which stem and leaf plot correctly represents the golf score? So remember, our stem represents our tens, and our leaf represents our ones. So immediately, I want you to think, which one of these answer choices can you immediately get rid of? I hope you said B. We can immediately get rid of B because if we read it as it is, this would say that he's got a score of 677, a score of 668, which is definitely not the case. So immediately, I hope you got rid of B. The next thing we're going to focus on is how to work smarter, not harder, because there are a lot of scores and we have a lot of information on each one of these graphs. So I would encourage you to take a peek and see if you can figure out what is different about each answer choice, right? If we take a look at the first one, right? They all have a 6 in the stem and then a 7 and an 8 in the ones. So those aren't any different. So we're not going to focus on that. The next thing we're going to take a peek at is the bottom, because they both have a 9 in the stem and then a 1 and a 2 in the leaf. So there's nothing different about that. Then I'm going to take a peek and see, is there a section where they all have some different answer choices? And you guys, I'm taking a peek at the 8s, right? The scores in the 80s, because this one's got a 0, a 1, 4, 4, 5, 5, 7. This one's missing a number, and this one is also missing a number. So, right, the 7 for the stem is the same for A and C. So if we can sort it out, we might be able to only have to look at a few numbers rather than a lot. So I'm going to highlight all of the 80s. There's an 80, there's an 80, 80, 80, 80, 80. Then I'm going to check to make sure we didn't forget any. No, 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 no. All right. So that means we need an 84. Well, this one's got an 84, this one's got an 84, this one's got an 84, so that's done. 85, 85, 85, 85, another 85, all right, another 85, ooh, no 85, they're missing one, boom. All right, so now we can at least get rid of C. We need an 80, well, there's an 80, and hello, this one has no 80. So D is out as well. And we did not have to sort through every single answer choice on that one. We just kind of worked smarter, not harder. All right, let's take a peek at question number 2. Ms. Kirk surveyed her students to see what their favorite food was. The results are shown on the tally table below. Let's see, what's that missing word? That missing word. In which table do the percentages represent the relative frequency of these food choices? All right, so basically we're trying to match up our tally table with a percentage table down below. So I want us, again, to work smarter, not harder. I want us to look at our answer choices and see if there are any that just seem absolutely unreasonable. For example, I see chicken nuggets. Chicken nuggets is the lowest out of all of them, right? And only got 5 people that said they prefer chicken nuggets. Which answer choice can we get rid of because it is unreasonable? I hope you guys said B. I hope you said B because it says that half the people chose chicken nuggets, which is totally bogus. Very few people. So immediately, I hope you guys X'd that one out. And then the rest, well, we might have to really kind of do some nitty-gritty math work. So if we're talking about percents, remember percents are out of 100. So that means we need a food out of a total in order to be talking about a percent out of 100, right? So if we take a peek, and I'm going to add this over here, that way we can put our food and our total. we need to get the total, because if we eyeball it, our total right here, guys, is not 100. So let's add up the values that we have. I'm going to chunk it. So I can see 15 plus 5, that gives us 20. Then I see 12 plus 8, it also gives us 20, and then plus this 10. That's a nice, quick one to add up. We get 50. So that means our total is 50. All right, so now let's think about it. Reasonable estimation, and it might be helpful if you do a practice problem like pizza or something like that. And this might be a good one, because if we look, the percentages are different for every pizza. So if we test out pizza, we might be able to eliminate some unreasonable answer choices. So our food is pizza. All right, we plug it in, and then we're just going to ask ourselves, nothing fancy, how am I going to get that percentage going from 50 to 100? We're going to multiply by 2, right, times 2. And that's essentially what we would have to do for all of them, because all of these are out of 50, and to get to their percentage, we're trying to get it out of 100. So we're essentially going to multiply all of these little nuggets by 2 in order to get the percentage. All right, but again, right, maybe we goofed. Let's check another one, because for hamburgers, they're all different. For hamburgers, again, we'd have to multiply by 2, and 10 times 2 is 20, so that's looking good. That's wrong, and that's wrong. So I think it's safe to say that C is our correct answer for number 2. All right, let's move on to number 3. Number 3, what is the interquartile range IQR of the data displayed in the box and whisker plot shown below? Remember, interquartile, it's a fancy word for the box. So we want the range of the box. All right, so that means we want the low of the box to the high of the box, right? Range. Think of Ariana Grande. She can sing really, really high, but she also can sing really, really low. So get from 80 to 90, the difference between that is 10. Right? Our range, how far apart are the high and the low? All right, let's take a peek at question number 4. Danny has received the following quiz scores on his last 5 social studies quizzes. 88, 94, 98, 90, and 85. Danny's doing pretty awesome. What is his mean or average score? Remember, my mean teacher gives me grades. That means we have to add up all of your grades and then divide by however many grades you had, however many numbers we just added up. So we're going to add up all of these scores. 88 plus 94 plus 98 plus 90 plus 85. And to keep this brief, I'm going to go ahead and punch this in my calculator so that we can get along with the tutorial, because if you have the right process, if you're adding up all the numbers and dividing by however many you just added up, but you somehow didn't get the right answer, you have the right process. We just need to make sure that you maybe need to double check something like your work. So we've got to add all of our numbers, and then we're going to divide by however many assignments or how many numbers we just added, which was 5. This is a good quick little example of PEMDAS, you guys. This means we have 455 divided by 5, right? Just a basic division problem after that. We should end up with, boom, 91. So if you goofed on this one, check to make sure that you added up your numbers correctly. That might have been where you might have gotten off a little bit there. All right, let's do question number 5. Box and whisker plots. Oh man, box and whiskers. This box and whisker plot shows the results on a 20-point math quiz in Mr. Wright's class. What percentage of the students scored 10 to 14 points? All right, so I'm going to highlight that section. 10 to 14 points. That's this section right here. So I gave you guys a hint, but let's think about it, right? We know this graph represents 100% of our data. From here all the way to the end over here, that is 100% of our data. 100% of the students are represented. However, the data is chunked into 4 parts. 1, 2, 3, 4, right? Quartiles, right? Each section is called a quartile. That's where we get the fact that it's divided into 4 parts, right? That prefix. Remember, no matter how big or how small our section might look, each section has the same amount of people represented. Think back to like our little deli experiment, or not experiment, but our little deli example that we had in class. If our section is really small, that just means that the data, the people represented in that section, are really similar to one another. If it's really broad, like we have here, that means that our data, our people, are really different from one another, right? We had that little section, super little, because, a lot of people lived really close to Little Delhi. But then we had that really long whisker because that last 25% of our data, those people were very different in how far away they lived from Little Delhi. All right, so a whole graph represents 100% of our data. It's broken up into 4 sections that all have the same amount of data, the same number of people. So essentially, we're taking that 100% and we're splitting it into 4 parts, which gives us 25%. Remember, think about it. Quartiles, quarters, a quarter is worth 25 cents. So a quartile is worth 25%.